Everyone. Monday night, we are back. Last Monday night, I had internet problems. So tonight we are with our regular show, The Physicist and Philosopher. Hello, physicist. I'm the philosopher. You're the physicist.
Hello, Wayne.
How you doing?
Here again.
Well, it's good to see you, Dr. Albers. How have you been since the last time we met?
Yeah, I've been well. Thank you. Busy. Trying to write as many articles as I can.
You are prolific at that, I have to say, and it's very, very, I enjoy it. It opens up new channels of thought.
I enjoy writing. I actually do a lot of thinking whilst I'm writing.
Well,
it slows my brain down just enough for me to think more deeply about the connections between things. That's why I enjoy actually figure out a lot of things whilst I'm writing.
You see, when you say that, and hello, all the moderators. Hello, everyone in the chat room tonight. Just want to say hello. When you talk about slowing the mind down, I think a lot of people have that challenge, and it is a discipline to be able to do it, isn't it? To slow the mind down.
Yeah, in order to see connections properly and to form a clear vision of all the concepts you have to think about, you have to slow your mind down. Sometimes the mind just wants to run along and then it misses the details. Yeah. This is why in physics we teach students to draw diagrams, and they never want to in the beginning, because they have to slow their minds down to draw the picture and put all the details on the picture. It's only once you've drawn that diagram that you start to realize what the problem really is that you're trying to solve.
Interesting.
Yeah.
Well, you know, my background, I started in the video post-production industry, and the part that I was in, it was the editing. And very back in the early days, that's in the late 70s, we began to bring in digital. And so computers have always been a natural thing for me. You know, I worked with it. We did high-end graphics, the national spot. So when I hear you say that, because that's how I had to learn about computers and understanding how a disk is actually formatted.
Yes.
Yeah. So, well, we've got a full room coming in here.
Wonderful.
So I know Scott's going to be joining us, and let's see. Dawn says, I got to meet Dr. Albers and Scott last weekend. So Dawn Stoll?
Yes, she brought us a puppy.
Oh, she did?
Yeah.
Did you get a dog? What kind of dog did you get?
A Dachshund. I think that's how you say it.
A dachshund?
A dachshund. That's right. Oh, he's so cute.
They are cute.
Oh, they're so
Tiny
cute.
little
He's just
legs.
a little puppy still.
Hi, Brian. How are you doing? Brenda, good to see everyone. Well, let me see. I think Scott's been waiting patiently, and I have a couple of things that...
sorry, Wayne. Scott says that you need to add him to the Zoom. Maybe he's ready.
No. Well, we know this is, let's see. Yeah, I see him here now. Okay.
Do you see him?
Yeah, I do. Okay. So we'll get him over here. And there he goes.
Ding dong.
Hello there, Scott. How are you doing?
I'm doing pretty good, my man. How are you?
Doing good, doing good. So everyone's here. I thought to make the best use of our time, I wanted to show a video of the, and allow me to pull it up here, folks. So I'm driving with one hand on the wheel and the other one outside. So give me 1 second. The volcano in Hawaii is just doing some amazing stuff. So, folks, this is Big Island Video News, just to let everyone know. The video was shot by Paradise Helicopters, which my wife and I rented one out for a half a day. We went up there to this was when we got married 7 years ago. And I can tell you, we got the videos. This was not going on. So I just thought I'd let everyone see what is happening in what I just think is like, I get the feeling this is like an artery that has been opened up on the earth. Because, would you agree with that, Dr. Albers?
I fully agree. That's a very good analogy. It's obviously this magma is not stopping. It's found a way up from the outer core of the earth. And the fact that it's flowing faster and faster shows you it's hotter and hotter. So we are actually getting lava coming from the outer core of the earth, coming straight up. It's found a way all the way to this volcano, and it keeps coming out. There's no slowing it down, it seems.
Look at that.
And people have been asking me, no, it's about the silicon content. But you see, the silicon, you get more silicon closer to the surface because silicon is a low density mineral. So it's closer to the surface. You get more silicon in magma that's closer to the surface. You get lower silicon from magma that is further down and that is hotter. So the two always go together.
By the way,
I'm going to write something on that.
Good. I also read that all this magma, and I'm going to let this video play out because it's quite fascinating, is that also this magma is the magma that was present in the last polar flip, the magnetic flip of the Earth. This is how old this magma is.
Yeah, this magma has obviously been it comes from very far down. You see how fast it's flowing. It must be very hot. And it must be hotter than the magma that we usually get coming all the way up to the surface. So we know it's coming from deeper within the earth. And so it's obviously found a way through. But, I keep saying that this is likely to happen because the earth is heating up from the bottom, from the core. So then the magma in the outer core of the earth will heat up. And when it heats up, it expands. And when it expands, you will try to find a way out of there because there will be increased pressure.
When you were saying that, I got this image in my head about the frog sitting in the pot and it's starting to boil, and the frog isn't realizing it's being cooked to death.
That's right.
Well, this is dramatic video. I just thought I would share this for everyone. Go over there, check these folks out, subscribe to their channel. I think it's some great footage. So anyway, there you go. I just thought I'd share that. And I know that we were going to get to last week get together. Scott, you had something you wanted to comment on that.
What were we going to talk about? My mind is like.
I think it was the earthquakes or something, Scott, wasn't it?
Yeah, I've been so busy lately, like literally pushing 16-hour days, 7 days a week. It's been I forgot today was Monday.
Well, you need to relax. You've got to give the mind a break. So it's important.
I do have one comment on the lava flow.
Yeah.
Never before, and I've watched plenty of lava flows. I've watched probably thousands of them. Never before have I seen lava in its fluidity act like water.
It is kind of, it's bizarre.
I mean, if you really do look at lava flows, I've been looking at it nonstop, but lava flows, usually it's kind of like thick.
Well, like I said, we got married and we went up there to Mauna Loa, and the cone, all it was doing was just smoking. I mean, you could go to the observers part. I mean, and it was still out there. Not anymore.
Yeah.
And the lake.
This lava's flowing fast.
Yeah.
I did a report yesterday and one today, and they were showing lava boulders just free flowing in these rivers of lava. And I was talking to Claudia about this yesterday and probably the day before. And I said to her, I said, you know, for that lava to look so thin and flow so rapidly, it has to be hotter. It has to be in the neighborhood of 3, maybe 4,000 degrees.
It's there's a young man who he's still on the island. He lived right next to Lonnie Estates, and he does a great video diary each day. And what I did not realize, that river is approximately 100 feet above that flowing through. And they said yesterday it was flowing at a rate of 15 square yards a second.
Wow.
I mean, that is like serious flowing.
Yeah, I didn't even know that lava could flow that fast. So this is unprecedented. I don't think it's ever been seen before. This kind of flowing rivers of lava. It's just unbelievable.
And to watch the cone now, that's what's been fascinating. When Fissure 8, when they first saw it opening up in the ground, you can go back on the gentleman's channel and on that one as well. And there was a house there. There was a house there. And I'm thinking to myself, that house was no longer there, but was sitting on top of what now is an artery. I don't know. How else do you say it?
Yeah.
Well, so that is strange. If y'all don't mind, Claudia, you wrote a paper that I thought that we could share.
Yes.
Because what you were saying in this paper, well, I think it needs to be said to the public. So I'll do you the driving and you can do the narration.
Yeah, I actually found one of Scott's videos on his channel because I'm looking for observational evidence, and I've been posting them on my own channel now. And so I found one of his videos where he caught these objects, and I decided to find out how large they really are. And well, this one is quite clear. This one is obviously not far from the sun. You can actually see the sun's jets superimposed upon it. So it cannot be very far from the sun. It's perhaps not in the inner corona, but it's definitely in the outer corona. So it's close enough for us to make a size comparison with the sun. And it's obviously 3 times the size of the sun, because the size of the sun is indicated by the white circle. And this is a stereo A core 2 image. So this, again, was also caught by Scott. It's one of his greatest captures. And it's 3 times the size of the sun. It's huge.
That's big.
It is.
That's all I gotta say.
The largest.
That's big.
Yeah.
I think in this photograph, this object was a lot more closer to the stereo craft than it was to the sun. It was a very unusual situation capturing that, because that was during another one of the larger CMEs that we had.
Yeah, that was the big one. That was what they're saying now was an X20.
Yeah. There was just a small X flare on the sun. Oh, I think it was on the 19th. I captured it doing some, my day to day, and it was small, very, very small, but it was clearly visible. I did a short video on it, and I think we might be seeing more of that. The sun is supposed to be calming down as we vastly approach this solar minimum. And it looked like it was doing that all of a sudden sunspots are coming around, a lot of activity, some small CMEs, and this small X flare. So there may be a very high possibility that things are going to start picking up on the solar level for what? Some unknown reason.
I'm looking at the smiley face.
Now, so if we look at this object and why I say it's in the outer corona, don't forget the stereo spacecraft is at 1 AU.
Right.
The sun's outer corona is about 0.05 AU. It's a very, very small distance. This object was obviously seen within a CME, and that means it had to be within the outer corona, which is 0.05 AU from the sun. And it could not have been very far towards the camera because it was seen within the CME. And the CMEs that the stereo spacecraft captures are when they are moving within the outer corona. So I would say this object had to be very close to the sun.
And one of the things I know people back in the day when I was into the research that would say, well, how can you have these objects next to the sun when no one on the earth is seeing them? I'm going, well, excuse me, how would you see anything next to the sun to begin with?
Exactly.
Yeah.
I mean, maybe call me simple, but I'm not getting it. So the next one here.
The other thing is that we have discovered is that these objects are captured by the sun. They come in, they form a connection with the sun. They never move very far away from the sun after that, unless they've been captured by another planet in the solar system. So this is another one of Scott's captures. This is from an HI1 image, and you can clearly see the spherical solid object there. And people say, oh, it's transparent. But it's not transparent. Those spots, and this actually indicates that these are not stars. These spots that we see in front of this object are due to the debris brought in by the stellar cores, because they share their outer layers. And then there's this material. Sometimes they may be moon-sized type of material. But if these were stars, don't forget the nearest star is about over 4 light years away.
Yeah.
So if these are stars, you can imagine this object would be larger than a couple of galaxies put together. So we know that these spots cannot be stars. They are material within the solar system. They are debris. They get ionized because, like all debris close to the sun, they will absorb material. This material become ionized, and then they'll start emitting light. It's like the stellar core start emitting light after a while as well, because of capturing material, ionizing the material, just like comets do it. That's why comets have a coma.
Excuse me.
Yep.
You see, so that's the first thing we have to realize, is that the size of this object actually proves that these spots we are seeing in these images are not stars. They are debris brought in by the stellar cores.
Is this Earth or is this Venus? I forget. There is this.
I'm not even sure what the objects are in these images, to tell you the truth. I wasn't actually concerned. We actually see comets there on the right hand side. Those were comets. I'm not sure what the planets are.
This is really interesting. When you really get this magnified up, you can actually see.
And what is surprising is how large this object really is. And you were saying that people ask, how can we get such large objects close to the sun? And this is why I discovered how gravity works. Because these objects are low in energy, and gravity is actually dependent on the energy of an object. These are dead objects. Dead means they have no energy in their cores. So their gravity is extremely low. So they don't act like normal solar system objects. If they were acting normally, they would collide with the sun and destroy it, because they are huge. They have huge mass. They still have that mass, but they don't have the ability to create a strong enough gravitational force.
Yeah, I have excuse me, I have some higher definition, excuse me, my goodness. I have some higher definition photographs of the photo that you're showing.
Mm-hmm.
And, you know, sometimes when you're using these photographs and you're putting them into these documents, sometimes some of the resolution literally goes away.
We do lose some of that.
Yeah. But whenever I show them on my my videos, I have them, the video's a 1080, you know, so it's a higher resolution, but the actual photographs I've converted into 4K. When you see these photographs in ultra high definition, now things are changing. Now those little dots don't look like they are, you know, or that object, the large object, looks transparent. So I've tried to explain to people over the years, when you're viewing these types of objects in these photographs, those little dots look like they would be background stars, but they're not. You know, and Dr. Albers' explanation of that was absolutely perfect. And one thing that I try really, really hard to do is make people understand the sizes of the planets in our solar system. I mean, I would have to say they're relatively small compared to the massive giants that are out there within our galaxy. We don't even know. As far as the stars go, I mean, there are stars that are way more massive than our sun. They would make our sun look like a small dot.
Yep, so, Beetlejuice.
Yeah, and I don't think that people really fathom the size of some of these objects. You know what I mean? We're always looking at them in photographs, or, you know, or through a telescope. Mm-hmm. I mean, could you only imagine being in a spacecraft and approaching Jupiter, even from 1,000,000 miles away, how massive it would look? So, you know, people's, the way that they judge these photographs, you know, I'm used to looking at them. Dr. Albers is used to looking at them. You're used to looking at them. So things in the photographs, you quickly define.
Yeah.
You know, and it's, we're still teaching people, new people come aboard every single day. So, you know, it does get a little repetitive trying to explain those images, that those are not stars. That's debris matter. And some of those pieces of debris, like Dr. Albers said, they could be the size of our moon or slightly bigger. Some of them could even possibly be the size of Earth.
Mm-hmm.
Mm-hmm.
So the distances and people being able to fathom how big space is, how big these objects really are. You know, we're not dealing with some little teeny tiny object like Mercury or our moon. Okay, we are dealing with massive, you know, stellar structures, man. You know, sometimes people just have to sit down and think about it. And that's why I tell people, look, take a screenshot from my videos. I upload them to our Planet X News Facebook page so people can download them and they can review them and look at them and play with the photographs a little, you know, and really, really start to learn how massive these objects really are. You know, they're not just little teeny tiny little dots like they look like on the screen. These are massive monsters.
And we've lost stereo B, so B is gone. And I contend it's not gone. I think that they have merely taken it offline. It was revealing too much, and too many people like us were. And you know, I just want to give credit to Yellow Rose. Her early research is probably, I think it should be fundamental course 101 for people to begin to understand what's going on out there.
Yeah, her and Debbie Blue.
Yeah. And I don't know what happened to them, but wow, that's all I've got. The NASA Wars is something everyone should watch.
Yeah.
I mean, I got the story, what happened to Debbie Blue, and I actually was privy to finding out who she really is. Wow. And the story is just absolutely mind-blowing. And I don't want to, I'd be honest, she still is employed
Well, I'll tell you what I did. I have a friend who works in Huntsville. And when I came across, when she let him out in 2012, I still remember what he said. He said, "Where in the blank did you get this at?"
Yeah.
And I said, "Well," "you worked on the damn thing."
Uh-huh.
Yeah. He went, "Yeah, that's right." So anyway, what are we seeing here, Dr. Albers, particularly?
Can we just go back to the previous image, because I wanted to mention something there. And again, this is the blue stellar core. And again, this is one of Scott's greatest captures, and he photographed it through his telescope. At least the one on the left. The one on the right was captured by someone in Germany a few weeks later. And this object close to the sun was about a third of the size of the sun. And from this, I could see this is why I started calling them stellar cores, because I could see they were solid objects that were losing their outer layers. It had stripes on it before, and it was losing the material that was making up these stripes. So this shows you where the debris comes from. These objects lose their outer layers of material. And don't forget, this is a core of a star. That means that the object was once much, much larger because it had layers on top of the core. But because they are dead objects, I expect that they will expand in size, including the core will most likely expand in size as the object gets more and more depleted in energy. So they're possibly larger than they were as living stars or planets. There's not actually much difference between a star and a planet, I've discovered. But basically, it's size.
They're all formed from the same dust, right? I mean,
yes,
yeah.
Actually, I found out there's not much difference in size. The stars are larger, have more energy, generate a larger electric field, and therefore emit more light, or able to emit a lot more light than a planet can. But even a planet like the Earth emits light when there is lightning in the atmosphere.
Go 16. Check it out, folks, if you haven't.
You know, Wayne, I wanted to add real quick, you know, after these discoveries were made in May and July of 2017, that is pretty much the time that we lost contact with all of our German subscribers, pretty much all of our European subscribers, except for the people in the UK.
Yeah.
Because the photograph on the left, that's my photograph. The photograph on the right was taken from an observatory. There was a small team of German. They called themselves astronomers and scientists, and they had been watching my videos. They watched some of the live streams that Dr. Albers and I did, and they started investigating themselves. And their investigation was quite some length of time. It wasn't just after seeing my videos. But yeah, I got that email with a whole host of photographs, you know, asking for their privacy to be, you know, to held back. They don't want any type of notoriety. And there you go. Shortly after that, all of
they
our
weren't there anymore.
No, they were not there. And I returned several emails to the email address. They just bounced back.
Yeah.
So I, you know, early on in 2016, I had a gentleman in Switzerland that was taking some absolutely astronomical high-powered telescope photographs and showing me these things. And, you know,
yeah,
they've disappeared now. Switzerland, you know, I've been talking about this now for the last couple of months. You know, there is heavy filtering going on. These European countries, I'm telling you right now, they do not want their people watching this. One of the only ways that they can actually see this, our reports, is if they're using a cell phone from an American company, like T-Mobile. I know a lot of our people that watch our videos over in like Indonesia and India, and we even have some followers in Japan, China, and Russia. But some of these countries, they're only viewing us on a cell phone. So that means the internet access to YouTube, and through filters, they won't be able to even know that our channel exists anymore. It won't show them anything, even in a search. I mean, that's how powerful Google is. Google rules the world as far as, the search engines and their AI.
Well,
you just can't fight it.
No, it's God. So,
Okay.
Getting on back on our focus here, it's what are we seeing here?
All right,
Claudia?
so I put in this. This is the SRAM version of the first image.
Okay.
I just want to show people that this is not a lens effect. It's not a lens flare, because the SRAM images in the SRAM detectors detect particles, not light, and therefore you cannot have a lens flare in the SRAM images, and therefore this object cannot possibly be a lens flare, because of course the trolls will always try to say, oh, it was a lens anomaly. So I just put that in just in case they try that one.
It's I won't even go there.
SRAM images. It's not
the reason why we get lens flares so much down here is you've talked about this, we've talked about this, and I'm going. So, folks, this thing is 1 AU away from the sun. The lens flare is a real problem up there. Okay, moving right on
anyway,
along.
Again, I'm using the fact that we know that the stellar cores are always close to the sun. They do not move very far away from the sun. Once they're captured by the sun, they will stay close to the sun. They move in and out. They go into the inner corona, almost touch the sun, make a connection. They are ejected through the CMEs, but they come back all the time. They stay around the sun. Just like the ones that are captured by the Earth will stay close to the Earth. They come in close, they move further away, they go into an orbit, but once captured by one of the solar system objects, they will stay with it because they are absorbing energy from that object. They will not move away. And that energy is slow in getting absorbed as well, because the very low gravity means that the energy absorption ability is low. It's slow. It's very slow. But they will stay close because it's like an insect being attracted to the light. It will not move away.
Throwing gasoline on a flame.
Exactly.
Well, and that's the other thing that, I think people fail to remember is that our sun is still pulling in objects. It still has the largest gravitational pull in the solar system. And, well, I used to think that until I started thinking about the moon, but I won't even go down that road. So anyway.
Yeah, but in this case, it's not about gravity at all. It's about energy. The sun's still generating energy in its core, so is the Earth. That's what attracts these objects to the sun and the Earth and all the other planets in the solar system, including Mars and Venus, Jupiter, Saturn, all of them.
I agree. And by the way, more and more people, Claudia, are observing, talking about stellar cores. Mm-hmm. I pass on to you the emails that come in, and people are beginning to look into the sky and beginning to say, okay, what am I seeing? And they start beginning to connect the dots. Yeah. So what do we have here?
So now I want to figure out how large this object is, assuming it's close to the sun, because as I said, from what we've discovered, it is logical that it's close to the sun, or it's at about the same distance from the sun that the stereo spacecraft. From the stereo spacecraft point of view, it's very close to the sun, so we can do a size comparison. So in these images, all I'm doing is trying to figure out how large the sun would be in these images. So what I did was I put together, these images are from 2007. I put together HI1 images with Core 2 images. And what I did is I placed them side by side, matching the size so that a CME coming from the sun, you see that the time is about the same. I tried to match the times. So I could join the size of the jets coming from the sun with their size on the HI1 image, so that I could then have a way of figuring out the size of the sun in the HI1 images. And the size of the sun in the Core 2 images is given to us by, again, that white circle on the occulter, that black circle, there's the occulter.
By the way, good work.
Yeah, thank you.
Yeah, no, it's good work lining up the two. I mean, that's the type of research that people will not do, and then they want to argue when this is great. This is, I like.
And I didn't just do it once. I did it twice to make sure I did with this one as well. This one's from 2011. And again, I aligned the jets from the sun so that I could have a size of what the sun would be in this image, and that's given by that yellow circle, which is the same size as the white circle on the Core 2 image. So now we have the size of the sun, so now we can do a size comparison between the sun and the objects in that image.
Okay.
So now what I did was I took the green image where we have the object, and I placed the HI1 image where the yellow circle is, and I sized it so that the same size, and then I had the size of the sun. And then I took that white circle and I drew the diameter of that object with the circles, basically. And there are 7 of them filling up that diameter. So that means that this object is about 7 times the size of the sun.
Choked up there. I looked at that and started realizing, so the sun is approximately, what is it across? I know it's
865,000 miles.
Is that what it is?
Yeah, it is about.
Okay. That's big.
It is. It's huge. The sun is huge. It's 100 times, its diameter is 100 times that of the Earth. Okay, so the sun is 100 times the size of the Earth. And this object is 7 times the size of the sun. So it's 700 times the size of the Earth.
That's big.
Yeah, you see, they fool us with these images by sizing them in such a way that, the sun is actually tiny in it. And then we don't realize that until we put HI1 images with the Core 2 images.
Yeah, because people will say, well, there's nothing bigger in our solar system than our sun.
Yeah.
And I go, well, who said that?
Yeah, right. Who's got the evidence of that?
Yeah, I mean, I want to know the guy or gal's name, and let's have a talk with him, because I've never heard that. In fact, Claudia, you would be able to address this better. When we talk about space is not limited by volume of an object. I used to think that gravity would tear a big object apart, but as you were saying, it's not always about the size and the mass, it's about the energy of the mass.
Yeah. The thing is, what I discovered is it's about energy, and this energy is in the form of photons. So gravity is actually a photon field. It all emanates from the photon and therefore from light. So when Newton discovered gravity, he discovered something that was working in a solar system where all the objects had about the same energy within them. And gravity is actually a combination of 2 forces. It's a combination of real gravity and the electrostatics interaction. So it's two forces, but he couldn't see that. He didn't even know about electric force. It wasn't even known at the time. And we've been blocked from understanding this. And it took these objects coming in and acting very differently from solar system objects for a physicist who's been trying to think, to realize, wait a minute, gravity is not what we've been told. It's different. Gravity is an interaction that's dependent on photons, on energy. And the energy, therefore, is what the driving force of everything in the universe. And it's energy that comes from a photon.
You see, I used to think, Claudia, that gravity was driven by rotation of a mass until I found out about Venus, that Venus makes one rotation in 284 days of Earth days. So wait a minute. That means that mass is barely moving at the center of it. Now, the atmosphere does it in 4 days. But my point is this, is that gravity is one of those, it still mystifies me when I think about it.
Yeah. You see, according to Newton, gravity is all about the mass and the distance between two objects. And then he gave a constant or proportionality to get to the force. And he said it was constant. What I discovered is that what he said was a constant in the solar system because all the objects had the same energy, but it's actually dependent on the energy inside the core of objects. That's why the stellar cores come into the solar system, and that constant G is extremely low for them. So if we have, say, something multiplied by another, say we have like a force is mass times acceleration. But imagine there's another constant in there. Let's just call it C. So we have a force is equal to C times the mass times the acceleration. But what if C is 0? What kind of force are we going to get? We're going to get 0 times the mass times the acceleration, which is equal to 0. The force will be 0. So the force these objects exert on another is close to 0 because that constant is close to 0.
Claudia, can I ask you a question? When Newton made his observation, he was predicating his observation upon a force that was being exerted on Earth. My question is this: how do we know that the principles of the equation, based on his observation of Earth, would be identical, let's say, on a planet like Neptune or another object in another solar system somewhere else? How can we say that the constant would be in every case?
That absolutely. Now, we know it works within the solar system. We know what G is within the solar system. But what astronomers have done is they have taken what we observed in the solar system and made it universal.
Yes.
They said it works like that all over the universe. We do not know that. And in fact, the stellar cores have shown us that it does not. G is not a constant. It's a constant for a particular object, and it was a constant in the solar system because all the objects were interacting with the sun, and they all had the same energy as the sun because they share energy between each other because they were in each other's gravitational field. So all the solar system objects had the same constant G, but the stellar cores came in and they did not because they didn't have the same energy.
Interesting.
Exactly.
Huh. I don't know if I can get rid of that now.
You know what?
It's a great tool.
I wanted to, add something real quick. A lot of our viewers, a lot of our followers, like I said before, a lot of them are very new to all of this. Maybe some of them never really delved into space matters, from childhood on. Maybe they didn't pay attention in science class. Who knows? but it's still it's a constant learning curve every single day. The one gentleman that sent in those photographs from Germany, in a few emails that we had back and forth, we talked about space and deep space. And he put it to me like this, that every planet, every star, every object in space is unique. There's nothing else out there like it, period. And if you notice, the planets that are in our solar system, each and every one of them is completely different, unique. So when these scientists from the mainstream pop in and they make these these comments about, like they know it all, when in fact they know absolutely nothing.
Yeah, and in fact, it goes further than that. Scott is absolutely right. They know nothing. But the thing is, they've turned everything upside down. When they say there's a black hole at the center of a galaxy, it's the opposite. There's matter creation, like a white hole at the center of galaxies. I've written about this over and over again. This is what I discovered. This is what astronomers that were really serious, like Holton Arp, and I know you have the book, Wayne.
Yeah.
What he discovered, what his observations led to this, that there is matter creation at the center of galaxies. And I've taken it further. I've used Holton Arp's ideas, and I realized there's matter creation happening from stars. It happens everywhere. Galaxies create matter. They form stars and planets from the matter that they eject. And stars eject matter as well. This is where the solar wind and CMEs come from, is a matter creation event. It's light turning into matter.
By the way, Claudia, did you know last Tuesday on my birthday that the solar wind measured the lowest speed that it had ever been measured at? Less than 200 kilometers a second.
And what do you think would cause that?
Yeah, you see.
Well, I don't know. If it was my electric bill, it would mean like we've got no power, Jack.
This is exactly.
We've talked about that before, and let's just face it. I mean, if you have a wind, let's say, or we'll just use wind as in like real wind. If you have an opposing wind at a little bit of a higher speed, well, what happens to the wind stream A? It slows down.
In fact, so Claudia, I want to show you something. Go ahead. I'm going to pull something up.
Yeah, it could be an opposing wind, but don't forget the sun is dying because of the stellar cores draining it. So what do we expect a weakened star to do? Well, it's ejection of solar wind, its production of solar wind should slow down. And it may slow down in burps. It may slow down. Each time it slows down, it probably slows down even more. And this is what we are observing. We're seeing a very slow solar wind. So there are actually three possibilities. We could have an opposing solar wind, and we do expect the sun to have weaker and weaker production of solar wind because it's getting weaker. And it could be that it's being eclipsed by one of these very large stellar cores that will block the solar wind as well. In other words, a very large one comes between the sun and the earth, and then the solar wind has to go around it.
Yeah, I mean, that's definitely a very, very intelligent hypothesis. I mean, if you just visualize it in your mind, if you know exactly what we're talking about, it's a lot easier to understand. Taking for granted that we sometimes speak like everybody in the audience knows exactly what we mean.
Mm-hmm.
But you're talking about years and years of observation, years of research and learning and investigating on all of our parts to get where we're at right now.
So
we understand it.
So give everyone what we're talking about. This is representative of the solar wind, this color coming here, the gradient. We see these IMF lines, the Earth hits it, and then it has its natural reaction. The reason why I took this one, y'all probably realize it, is that I believe that what I'm going back now in my library, I think, Claudia, we've been capturing these stellar cores, and this is behind the Earth. So this is, you can see the polar magnetic line. Look what's happened here.
Yeah, that's when the magnetic field gets entangled. It's usually caused by high density solar wind impacting the magnetosphere. Oh my goodness.
So this happened last March. You can see on the 13th. Wow. And this is why I know there's something else out there.
Oh, definitely.
I stopped doing this because it was really beginning to freak some people out. And quite to be frank with you, it was freaking me out at times.
Oh, yeah.
Because I'm just being candid. I look at this now and I know it's coming back. But Claudia, when you see this, tell the people what's happening. Number one, no solar wind, folks. It's gone. Excuse me.
You see, the Earth is being affected by these objects. We now know that several of them are in orbit around the Earth. They possibly come right into the magnetosphere. They of course will have a magnetic field. They're making magnetic connections. They're making electrical connections with the Earth, and they're throwing everything out of alignment with the Earth. The Earth is being tossed to and fro by these objects. You can see what's happening to the Earth's magnetic field.
It's gone.
And the Earth's magnetic field, the outer magnetosphere, is actually created by an interaction with the sun. When the stellar cores come in close to the Earth, they will disrupt that connection between the sun and the Earth. And they will, of course, then disrupt the Earth's magnetosphere. And in addition, they are causing this energy to come out of the Earth's core, which is ionizing the ionosphere, which is increasing the energy on all levels from the surface, from below the surface, all the way through the atmosphere to the magnetosphere. Everything is getting energized. There's more energy everywhere. And then the stellar cores connect to that energy. And then there's an electrical connection there. And wherever you have an electrical connection, you're going to have a magnetic field. And that disrupts everything. And this is what we are seeing.
So to help
probably happen often and more often, because as the stellar cores absorb more energy, they get more effective at doing this.
It's like almost like a burst of static electricity that sends your hair standing up.
Yeah, good analogy.
Whenever you see these black magnetic field lines,
and they're supposed to be connecting to the other planets. They're usually very streamlined.
Exactly. And, I remember these instances that you're referring to here on the screen. And, we were seeing these occurrences quite frequently now because we once again heavily publicized a lot of this with the magnetosphere and the magnetopause models. I personally feel now that there is major manipulation going on with these models and what we're actually seeing now.
Yeah.
So give some people some background as well. So our scale over here, this is plasma, folks, tells us the heat. That's why it's hotter coming off the sun. But what got me on this one, you two, was the fact that the density of the plasma in its temperature, this is not normal. It's like it's almost being in a pot being mixed.
Yeah, the deep blue is very low density of particles. So it's like the particles that are supposed to be there are no longer there. It's like a vacuum. But what interests me the most is that the magnetic field has gone totally chaotic. It's like
look at that.
The magnetosphere
a huge
has been
burst.
totally disrupted.
So this is why, and people don't realize this. This is
and as Scott says, we actually started thinking that they turned these models into cartoons. Basically, they were not showing us what was really happening anymore.
Yeah, I've caught them. I caught them one time. They basically meshed together 2 different days into one model. Okay, to take out the abnormality, like what we were just seeing, and they put in a normal situation into that computerized model. Now, you know damn well it's easy to do. So I thought, okay, let me see if I could duplicate it with my video making software. Not a problem.
Yeah, of course.
Matched it up perfectly. Okay, and I don't have the technology that they do. So, you know, this has been going on since 2017. The more discoveries we make, the more we expose it, we're literally showing them how to defeat us.
Yeah.
As we've defeated them. It's just a fact. You know, they're doing it, and you know, I'm very critical of what I'm viewing now. You know, I'm having to go on what's happening to this planet right now. We already know that these objects exist. We already know they're there. I've warned people for years now. Okay, we're going to see these Earth changes that are going to be so dramatic, and we're literally on the beginning stages of it. We've gone through the earthquake stage, and the earthquakes are going to continue. But like I said, whenever we go into full volcanic mode, whenever we have multiple volcanoes with blasting, and I mean heavy blasting, continuous lava flows like what's happening at Kilauea right now, okay, that is the beginning of the Earth literally letting loose from the inside.
So I want to give credit to Joe Barty on this. This just came out last week. And what we're seeing here are the anomalies taking place in the Atlantic Ocean. And I want to point out 2 things that's alarming. What we're seeing up in here, going up into the Arctic, folks, it's cold, really cold, and it's bleeding out. And here's the strange little anomaly. We have this one pocket of hot water up here, but it's affecting everything. And I wanted to show you all this. And I want to go particularly to the world map. So here's what's happening up in the Ukraine right now. They're getting snow. They just had record snow, I think approximately 3 feet. It is crazy, folks. Same things happening over here up in Newfoundland. They have 6 feet of snow on the ground.
Yeah, there was a huge snow anomaly that just occurred in Peru, killing 600 people.
Wow.
Well, they literally went from a high normal temperature, dropped and dumped a mound of snow, dropped the temperature down to 5 degrees, and there were over 600 casualties. I just did a report on it a few days ago.
Well, they're in their winter time right down here, right? This is where I think Peru is. Isn't it over here?
No, Peru is close to the equator.
Yeah, so, and the equator's right here, isn't it?
Yeah.
Well, this is in the high elevation.
It's not supposed to have real seasons. It's supposed to be a good temperature all year round.
Well, this was in the high elevations of the mountains.
Yeah.
But still, that type of temperature drop and that type of snow amounts, even at this time of year, was drastic, literally overnight. The anomaly that you were talking about, Wayne, that's up there near Greenland, the one going into the Antarctic. Now, I've been following that for almost a year now. Okay, that anomaly has caused serious problems in our past winter. This past winter that just went by, that anomaly is what was creating all of the very low troughs in the jet stream, pulling down all of that cold air right over the Midwest, all the way down to Arizona and parts of Texas. I've been watching that.
Well, it's not good, I don't believe.
I believe that area that is circled up there and in the red, again, we don't know about all of the volcanoes under our oceans. That's a fact. Now, what would actually cause that type of massive heat exchange in that area of the world where that water temperature should be very cold, maybe in the 30s? Now, think about it. Is there a string of underwater volcanoes in full eruption and we don't know about it because they're not telling us? You know damn well that the geologists and the oceanographers, all them, they all know it's happening. So what can produce that? And that's in a devastating spot. Devastating spot.
Yeah, that's a very strong possibility. Yeah,
because that warmer water has been moving into the North Pole for the last year. Okay, climatologists have been talking about it. I research it and I follow it very, very closely. That is destroying the Arctic. New sea ice forms and melts so quickly. The old, thick sea ice is almost gone.
Yeah.
Start digging into what's happening up there in that Arctic, and it's going to blow your mind. I've been following it now for quite a long time, and I have great documentation that's put together every single day by legitimate scientists that are watching what's happening up there. There are a few of them there that are voicing their opinions and talking about it, and then there are some that are not.
Yeah.
And we know the reasons why they're not.
Yeah, we can see that seasonally the weather is not the same that it used to be. It's supposed to be warm over these land areas. So over Russia, it should be warm. Over Siberia, it should be warm at this time of the year. And for them to have snow at this time of the year is just not normal. So there's definitely something going on. But like I said before, what is happening is the Earth's is actually warming up. That's causing the volcanoes to erupt, which will be, as Scott said, mostly. The ocean floor is littered with volcanoes. And these volcanoes will be erupting, warming up the oceans. But what's happening to the land then? Well, the weather is not the same as it used to be. As the ionosphere heats up, and like our magnetosphere is going chaotic, our weather responds to what's happening to the ionosphere. Our weather patterns actually start in the ionosphere. The weather is electrical and driven by the ionosphere. And the ionosphere is getting heated, more energy due to the stellar core interactions. So that will make our climate chaotic as well. And so that's one of the reasons that this is happening. Also, I think we may not be in the same place that we used to be, because as the sun weakens, we would expect the Earth to move away from the sun. Then our seasons will be off completely. And what they are doing is they have artificial ways of creating weather. And with the stellar cores and everything else, it's just not working properly, and not working properly all the time. They're not able to control the weather properly. So we get these fluctuations of very cold weather, very hot weather all year round. And I even observed this in South Africa for the last few years, where the weather, instead of staying warm and getting a thunderstorm at the end of the day every day like we used to get, instead we have this weather where it's going up one day and down the other day. That's
there's no doubt. I mean, have you seen these massive
Wayne,
downpours?
your microphone is off.
Well, that's because probably most people want it that way. No, I know we've gone over, but, we experienced that yesterday here in Denver. 2 o'clock yesterday afternoon, it was 54 degrees in the middle of the day.
Yeah.
And Thursday, it's supposed to be 100+ degrees. So we're seeing it. It's exactly what I would expect. And my feeling is I don't think we're looking at global warming. We may be going into a global cooling.
It's going to be a roller coaster.
No doubt.
Yeah, you're definitely going to have some areas that are going to experience way below their normal temperatures, 25 to 30 degrees, maybe even 50. And then you're going to see other areas that are going to get extremely hot. Once again, look what's happening in India. They're having record-breaking heat. In the southwest part of the United States, record-breaking heat. Okay, there was a recorded temperature in India last week of 120 degrees.
Yeah,
okay? So I think we're going to be on the roller coaster for the rest of our lives. I mean, there's no doubt about it. People are going to have to get adjusted to the earth changes. And they're going to have to start understanding what is happening. You know, the life that you lead now may change drastically in a month, 6 months. It will definitely change each year that we go through this. And there's no timeline on it. We don't know exactly what these objects are going to do. There are going to be some factors that are going to play into things like going into a solar minimum. That's critical. I mean, if our sun is already losing energy, going into a solar minimum could be devastating.
Well, yes.
I just wanted to say that we know that globally the oceans are warming up. We do get this cooling, but it's on land masses. The oceans globally are a lot warmer and have been for years. And that tells us that the Earth is warming up. And then the other thing about the grand solar minimum, we basically, according to the solar cycle, we are supposed to go into a minimum. But I've shown in a lot of articles that the sun has been weakening independent of the solar cycle. It's like the solar cycle's gone. The sun is just getting weaker and weaker, losing its corona. And don't forget, years ago, we could see already that all the planets in the solar system were warming up. This is not consistent with the sun going into a solar minimum, because then all the planets should be cooling down. And we actually know that Pluto warmed up as it moved away from the sun in its orbit. What is this consistent with? It's consistent with the stellar course affecting the sun and affecting all the planets in the solar system. This is consistent with the sun weakening and continuing to weak. Because when people talk about a grand solar minimum, it's like, okay, we can ignore that we have stellar cores in the solar system now because it's the sun's doing it by itself. Furthermore, a grand solar minimum implies that the sun will recover. And what we have discovered is that the stellar cores are affecting the sun and they are not going to leave.
Yeah, that's the big problem right there. Dr. Albers just spelled it out for you right there. If the sun does not have the opportunity to recover, like in a grand solar minimum, this solar minimum could actually be accelerating and coming at us quicker. There was just some information that came out. I think BP Earthwatch did a little piece on it, showing the latest graph that came out. And I don't follow it that much, but you know, he showed the graph, and it was basically like we were accelerating, we were moving faster into it. Now, I know Jake over at Grand Solar Minimum does exclusive work on all of this. And, you know, I mean, I haven't had a chance to talk to him too much on this aspect, but, you know, I know he's been busy with all of the earth changes, all of the flooding, same thing with me. I'm watching all of these landslides. We're having landslides here in the Pittsburgh area in multiple locations on a daily basis. Roads are disappearing. We had flooding not 20 miles south or 20 miles north of us that literally wiped out the town of Bethel Park and other suburbs of the city. And I'm talking flowing rivers in neighborhoods, toppling cars over walls. It was insane.
Yeah, it's
not the kind of weather we have.
Well, it was a land-based hurricane. I mean, so it's getting it's strange. I think adjustment is going to have to be made for all of us. And Dr. Albers, that's why we have you. That's why you're writing the papers. That's why we get here each week.
Yeah,
I mean, it's a fantastic idea to have Dr. Albers on your show once a week, and
people like it.
Yeah, I mean, they're able to catch some quick lessons on what is exactly happening. Getting a scientific viewpoint of it is definitely something that everybody needs to do. It's easy, like we said earlier, to just take a look at a picture and say, oh, that's this or that's that. But, when you invest, 12, 14 hours a day, every single day, educating yourself on what's happening, I don't want to throw the word expert around, but, you're not a novice.
You're more, how shall we say, versed.
Yeah, exactly. Before we end the live stream, I know you went over a little bit. I was in contact today with a very nice lady who lives in Indiana, and somebody shared a video that she took maybe a few days ago, and it's quite incredible. We're going back into the two suns. She just happened to look up and she started noticing what was literally in the sky with her own eyes, then grabbed the video camera and shot some incredible footage. I had a chat conversation with her very early this morning on Facebook, asking her if I could, take that footage, convert it to 4K and, check it out. I showed it to Dr. Albers. I wanted to show it to you and your viewers because it is pretty mind-blowing.
Oh, that's right. Yeah.
What it looks like to me is it looks like we're looking at the actual sun setting and the sun simulator right next to it, burning away in pure white. So, I mean, if you don't mind,
go. No, please do.
Yeah,
let's see it.
It's a quick, let me just pull it up here real quick. And I need to get the video back to her so she could re-upload it onto her Facebook page. She has quite a bit of video. Let me go ahead and share this now that I have it. Okay. Are you guys able to see that?
Mm-hmm. Yep.
So I put this video together for her. She was using, I don't know if it was a cell phone or video camera, but I'll just let it play through and we'll check it out. This is a still photograph that I took. And this is what I was referring to as possibly our real sun in the setting motion.
You see, it looks like a perfect circle in the sky. So it's it most likely is our sun. The fact that it's at that position close to where they put the sun simulator, which of course looks white, and our real sun would never be white. And the sun simulator doesn't look like a perfect circle either, because they use the lens system and so on. So it actually often looks like a holographic projection in the atmosphere.
Yeah,
but the other one looks very circular, but it's darker than normal.
Here's another still shot from her video. And again, if you're looking right here, you can see this is in a sun setting motion.
When did she shoot this?
A few days ago.
Well, there is Indiana. 2 other people I know. Jim from San Antonio. He has footage of something very similar. And there was another person in Illinois that sent me some footage.
What this reminds me of is that the sun simulator is off center of our sun. And this occurred. Now, come on, let's be realistic, man. I mean, how are you going to get cloud cover over this object and cloud cover down here over the bright secondary light or primary light, whatever you want to call it.
Yeah, well, basically we have two light sources. That's obvious. But the thing is, the one that would be our sun, don't forget, it's coming down towards the horizon, but still high up in the sky. Our sun years ago would have still been bright yellow at this time. This object looks orangey red. And that goes along with the fact that our sun is now much weaker. So it's not even emitting the intensity of light that it's supposed to be emitting, if that is indeed our sun. It's not like it used to be. It indicates it's much weaker than it used to be.
Now, this is her actual video footage that she took. And she's obviously using some type of a lens, because you could see it in the lower left-hand corner. But I mean, when you watch this now, I cropped this and I converted it to 4K, which is coming up. So I've meshed these two videos together, give you her view and what I converted. Now, I mean, again, we just watched cloud cover, move past both objects, but different clouds. And this is now going to go into the 4K that I converted it to. I mean, come on, man. I mean, that's not a camera anomaly. Give me a break.
No, of course not. I mean, you could actually see the real lens flares at the bottom right of the image, two of them. The objects stay in the same pattern with respect to each other.
Look right
There's
here.
no way one is a lens flare of the other. You can clearly see they are all different colors. You can see that the sun simulator is bright and larger, and the other one above it looks like the real sun, because
I mean, how is this one being covered, almost all of it,
exactly
by cloud cover, and this one not?
Exactly.
I mean, I'll let the
Plus,
4K
if
version.
one was a lens flare of the other, they would be the same shape all the time. If half of one is covered, half of the other would be covered as well by the cloud. That's what we should see. So obviously not lens flare, but of course, the trolls always try that one.
Well, I'm glad that she remained calm and coherent. So that's the good thing. And otherwise, most people would have already said, Martha, let's get the kids and get the hell out of here.
Yeah.
Yeah.
So, well, thank you for sharing this, Scott. And
I mean,
wow.
it's pretty interesting. I'm going to go ahead and email it back to her so she could repost it on her Facebook page. And pretty outstanding capture here.
It's amazing. It's amazing footage. Amazing.
It reminds me of almost like an eclipsed sun, or the sun setting in the sky. At a later time, it doesn't have that brightness on it. You could almost see just the round orange ball in the sky. And now, I mean, that's what we're seeing. So to me, I mean, come on, man. I mean, that photograph right there, look, it's perfectly round, like a flashlight.
Yeah.
You can see the outer rim of it again. I'm working on some zoomed in photographs, which I'm going to convert to a higher definition. And we'll be able to see that this is a perfectly round circle. It is a freaking lens. It's bright white. And that's our real sun. That's our real sun. This is our fake sun. Normally, this fake sun would be over top of our real sun, blocking it out like they always do.
Yeah.
I mean, look at the cloud formations now that people are seeing. There's a lot of weird things going on in our skies right above our heads.
Oh,
Forget about space for a while. Just take a look up into the sky above your head and start snapping some photographs and start analyzing them. And I'm sure that you're going to be pretty surprised at what you capture. Yeah.
Okay, folks. Well,
Time for a Xanax.
No, it's
that anxiety's kicking in.
It's we live in a time where illusion is so intermixed with reality that most people go ahead and take the blue pill and go right back to what they think is reality. And actually, what I've come to understand, it's really a self-defense mechanism.
Yeah, it is, because you see, the human brain, the way the human brain learns is if you learn something new, you have to connect it to what you have learned in the past, your framework. And if you learn something new and it's so new to you that you cannot connect it to your own knowledge, the knowledge you already have, you will lose that. You will forget it. And this is why people need to hear the truth about the stellar course over and over again, because it's so new, it's so outside of possibility from what we've been taught in school and at college, that we see, oh yes, it's there, I can see it there, but 3 days later, your brain has forgotten because it never was able to connect it.
Bingo. And I'm still trying to figure out, how did they get blue sand on Mars?
Yeah.
I don't know. And isn't it odd, folks, that we're no longer seeing the filtered pictures from Mars? Guess what? It has a sky just like ours.
It does, yeah.
Oh, wow. Well, you too.
It had oceans not so long ago.
Yeah, and not that long ago, apparently.
Yeah.
Much more recent than what most people. What Dr. Albers, again, a phenomenal classroom experience. Folks, eventually there's going to be a semester test. So just remember that. And Claudia, it's always a delight to have you teach us and give us, your vast knowledge. I always say it's an opportunity to take a nice detour trip into your thoughts, which are vast. And Scott, it's always good to have you on. You always got new information, and y'all two keep on going strong. That's what I love about this.
Yeah, most definitely. I just wanted to end in, just one quick comment for everybody that's out there, everybody that's listening. I know a lot of this may be hard to swallow. Maybe you don't understand it, but keep on watching. Keep on listening to Dr. Albers and also Wayne and myself at Planet X News.
Yep.
We're trying to keep people up to date on what is happening, at the same time teaching all of them. And pretty much everything that you thought that you knew about space and our solar system, as of today, throw it out the door. Because each and every day is going to be a new learning experience as we uncover these things that are happening. It's plain and simple.
Exactly. It's like when you order popcorn and you realize they gave you that rice cake instead.
Yeah.
You're saying, what happened here? All right, you two have a great week. Thanks, everyone. Thank you, everyone, to the moderators. Thank you for watching. We've had a full room in here tonight. And thank you all for joining us. Make sure to go over to Claudia's channel, Planet X Physicist, and then get into Scott's with Planet X News. The links are below. Buy their books. Go over on Amazon. Get the books. And I know you two are working on another one coming out. And folks, it's how you learn.
No doubt about it. Thanks for having us on, Wayne. Good seeing you.
Thank you all. Much love. Thank you. And emesit to everyone. And we will see y'all again next week. Okay.
Take care, everybody.
All right. Bye-bye, y'all.